We are now going to look at solving trig equations. To solve a trig equation, you have to find the angles for which the equation is true. Looking at problem number 1, we have 2 cosine of x minus 1 equals 0. We need to find out what values of x will make this true. The first thing you need to do is solve for the trig function. You can do this by adding 1 to both sides. So 2 cosine of x is equal to 1. Then divide both sides by 2. So you have cosine of x is equal to 1/2. Now, you need to use your reference triangle to figure out what angle has a cosine value of 1/2. Here's 30, here's 60, 1, root 3, and 2. So cosine has a value of 1/2 at a 60-degree angle. You also need to consider that cosine is positive in 2 quadrants. So all students take calculus. Cosine is positive in quadrant 1 and quadrant 4. Therefore, x could be the 60-degree angle in quadrant 1, which is pi over 3. But x could also be the 60-degree angle that's in quadrant 4. That is 5 pi over 3. Therefore, this trig equation has 2 solutions. Both pi over 3 and 5 pi over 3 solve the trig equation. Moving on to problem 2, we have the square root of 3 times the tangent of x is equal to -1. Again, we must isolate the tangent of x to solve this trig equation. Divide both sides by the root of 3 to isolate the tangent of x. We have the tangent of x is equal to -1 over root 3. At this point, we can go to our reference triangle. The root 3 occurs in the 30, 60, 90 triangle. This is 30. This is 60. We have 1, root 3, and 2. We need the tangent of what angle to give us 1 over root 3? That would be a 30-degree angle. Now, we have to consider the quadrants in which tangent is negative. Again, all students take calculus. Tangent is negative in quadrant 2 and quadrant 4. So we need to give x as a 30-degree angle that appears in quadrant 2 and in quadrant 4. The 30-degree angle in quadrant 2 would be 5 pi over 6. And the 30-degree angle in quadrant 4 is 11 pi over 6. Therefore, those are the 2 solutions to this equation. Moving on to problem number 3, we have 4 sine squared x equals 1. We have to first isolate the sine function, dividing both sides by 4. We get sine squared of x equals 1/4. Now, we want to solve for sine, but we have sine squared. Using algebra skills, we will square root both sides. Square rooting both sides, you then get the sine of x is equal to plus or minus. Remember, when you square root, you get both positive and negative answers. The square root of 1 is 1, and the square root of 4 is 2. Now, we need to use our reference triangles to figure out what angle gives a sine of 1/2. So we have 1, root 3, and 2. Looking at the reference triangle, you can see that the angle we need is a 30-degree angle. Now, because we have plus or minus 1/2, we are going to have an answer in every single quadrant. Sine is positive in quadrants 1 and 2, and sine is negative in quadrants 3 and 4. Therefore, by square rooting, you will get 4 solutions to your equation. Therefore, x is equal to the 30-degree angle in every single quadrant. Quadrant 1, pi over 6. Quadrant 2, 5 pi over 6. Quadrant 3, 7 pi over 6. And in quadrant 4, 11 pi over 6. Therefore, this equation has 4 solutions. When I look at problem 4, I notice that I have 2 different trig functions. I have 2 cosine squared x equals sine x plus 1. I'm going to need to make a substitution to get the trig equation into one trig function. Using Pythagorean identities, I can replace the cosine squared x with 1 minus sine squared, giving me an equation involving only sines. So we get 2 times 1 minus sine squared x. That's a Pythagorean identity, equals sine of x plus 1. Now, distribute the 2. You get 2 minus 2 sine squared x equals sine of x plus 1. I'm going to bring the 2 terms from the left side to the right side and set the equation equal to 0. 0 equals, putting the equation in descending order, you get 2 sine squared x plus sine x, and subtracting 2 from both sides, you get minus 1. Now, this is set up like an algebraic trinomial that needs to be factored. So 0 is equal to 2 sine of x times a sine x. Now, the last 2 terms have to multiply to 1, so I need a 1 and a 1. With the positive being in the middle, I need the outer sign positive and the inner sign minus. Those are Algebra 1 skills that you need to have in order to factor these trig equations. Now use the zero product property, set each piece to 0, and you will get solutions. 2 sine of x minus 1 equals 0. Adding the 1 and dividing by 2, you will get sine of x equals 1/2. You then need to use your reference triangle. I know that the sine is 1/2 at a 30-degree angle. Sine is also positive in quadrants 1 and 2. Therefore, this part of the equation produces 2 solutions. You get the 30-degree angle, pi over 6, which is in quadrant 1, and you also get the 30-degree angle in quadrant 2, which is 5 pi over 6. That is 2 solutions. Now we have to finish the other half of the equation. We set the sine of x plus 1 equal to 0. We subtract 1. Therefore, sine of x equals negative 1. Where does the sine of x equal negative 1? This is a quadrantal angle. This occurs when x is equal to negative, not negative, but just 3 pi over 2. Therefore, you have 3 solutions to this equation. X could equal pi over 6, 5 pi over 6, or 3 pi over 2. When I look at problem number 5, I notice that there are only 2 terms in this problem. I have 2 sine squared x equal to negative sine x. I'm going to bring the negative sine x to the left side and set the equation equal to 0. 2 sine squared x plus sine x equals 0. When I look at these 2 terms, I notice that they have a common sine x. That is the GCF. You need to factor that out front. So you get the sine of x multiplied by 2 sine x plus 1 equals 0. Now if you notice you have two pieces multiplying to 0, so you use your zero product property. You set the sine of x equal to 0. You also set 2 sine x plus 1 equal to 0. Going back to the first equation, where is the sine equal to 0? Remember, sine is the y-coordinate. So y is equal to 0 at the angles of x equals 0 and pi. Going to the second half of the equation, I will subtract 1. So I get 2 sine of x equals negative 1. Divide by 2. Sine of x is equal to negative 1/2. Using reference triangles, I know that sine is 1/2 at a 30-degree angle. Then, because the sine is negative 1/2, I know that sine is negative in quadrants 3 and 4. So I need to give the two solutions in quadrants 3 and 4. The 30-degree angle in quadrant 3 would be 7 pi over 6. The 30-degree angle in quadrant 4 is 11 pi over 6. Therefore, this equation has 4 solutions, 2 from each part of the factoring. If we look at problem number 6, we notice that there are 3 terms again. Probably will factor like a trinomial. Let's add the 3 cosine theta to the left side. So we have 2 cosine squared theta. Putting it in descending order would give me plus 3 cosine theta plus 1 equals 0. This looks just like a quadratic equation that can be factored. So we are going to factor. We have 2 cosine theta, and then we have a cosine theta over here. And this is equal to 0. The only numbers that multiply to 1 at the back are 1 and 1. Because the middle term needs 3 cosine theta, both of the binomials have to have a plus sign. Using the zero product property, we set each piece equal to 0. 2 cosine theta plus 1 has to equal 0, and cosine of theta plus 1 has to equal 0. Subtract the 1 and you get 2 cosine of theta equals negative 1. Divide by 2 and you get cosine of theta is equal to negative 1/2. Using my reference triangle, I know that the cosine is 1/2 at a 60-degree angle. Now, I need cosine to be negative. Cosine is negative in quadrants 2 and 3. So I need the 60-degree angle that falls in quadrant 2, which is 2 pi over 3. I also need the 60-degree angle that falls in quadrant 3, which is 4 pi over 3. Going to the other side of the equation, I subtract 1. So I get cosine of theta is equal to negative 1. Cosine, again, is the x-coordinate on the unit circle. So where is cosine equal to negative 1? That's when theta is equal to an angle of pi. So therefore, number 6 has 3 solutions to his equation. When I look at problem 7, it's a little confusing because I have a tangent x and a sine x in the same trig equation. I often look to make substitutions using Pythagorean identities. But Pythagorean identities only work when I have trig functions squared, which in this case, I do not have. So I'm going to take the tangent of x and convert it to sine and cosine and see if I can figure out what happens from there. Tangent of x is sine x over cosine x. This is then equal to sine x. At this point, let's clear the fraction by multiplying this entire equation by cosine x. When cosine x multiplies the term on the left, the cosines cancel, and you end up with sine of x. On the right-hand side, you get sine x times cosine x. Now, if I take the sine x cosine x and bring it to the left side, I can set the equation equal to 0. I then have sine of x minus sine x cosine x equals 0. Whenever I have two terms, I often look for the GCF. If you notice, both terms contain sine of x. Factor it out. I have sine of x times 1 minus cosine of x equals 0. I am now factored and can set each piece equal to 0. So you get sine of x equals 0. You get 1 minus cosine of x equals 0. Going back to the first equation, sine again is the y-coordinate. He is equal to 0 when x would equal 0 or pi. Going to the second equation, I'm going to add the cosine to the other side, and I have 1 equals cosine of x. So when is cosine of x equal to 1? Well, that also occurs at pi, which is a repeat from the first solution. So I won't even list it. There are two solutions to this equation, and they are when x equals 0 and pi. Looking at problem 8, you again may notice that there are only two terms. Therefore, often look for a GCF. Both terms contain a tangent x. I will take out the tangent x, leaving me tangent x minus root 3 equals 0. I now am in factored form and can set each piece equal to 0. So when is the tangent of x going to be 0? And then the tangent of x minus root 3 equals 0. Going back to the equation on the left, remember tangent is sine over cosine. That will equal 0 when the numerator equals 0. So where is sine equal to 0? That occurs when x is equal to 0 or pi. So the tangent of x equals 0 at 0 and pi. On the right-hand side, you're going to add the root 3. So the tangent of x is equal to root 3. Using reference triangles, which angle produces a tangent of root 3? Well, let's look. 30, 60. This is 1, root 3, and 2. So if you look at your reference triangle, the tangent is root 3 at a 60-degree angle. Now, the answer is positive. So using my quadrant information, all students take calculus, tangent is positive in 1 and 3. So I need the 60-degree angle in quadrant 1 and the 60-degree angle in quadrant 3. Therefore, x is equal to pi over 3 is my quadrant 1 answer, and 60 degrees in quadrant 3 is 4 pi over 3. Therefore, this equation has four solutions: 0, pi, pi over 3, and 4 pi over 3.